Herzlich willkommen zu dieser Sonderausgabe des Ada-Podcasts Shift Happens, die letzte in diesem Jahr 2023.
Shift Happens.
Es gibt ja wilde Ideen, wohin sich künstliche Intelligenz entwickeln könnte, seit ChatGPT vor fast genau einem Jahr eine neue Zeit der generativen KI eingeläutet hat. Müssen wir Angst haben, dass unsere Computer uns irgendwann sagen werden, wo es langgehen wird, dass sie sich reprogrammieren und eigene Ziele setzen, dass wir zu den Werkzeugen unserer Werkzeuge werden? Brian Christian hat auf diese Frage nicht die allgemeingültige Antwort, aber der US-Autor und Technologieexperte weiß, was im Zentrum dieser Diskussion steht: das sogenannte Alignment-Problem. Wie stellen wir sicher, dass die Ziele und Funktionen von künstlicher Intelligenz mit unseren menschlichen Werten und Zielen übereinstimmen? Wenn man mit Brian Christian spricht, was ich am Ada Lovelace Festival vor wenigen Wochen getan habe, dann begegnet man einem unaufgeregten, klugen Mann, der erst einmal nachdenkt, bevor er antwortet. Und das kann ja gelegentlich helfen. Christian sagt zum Beispiel, der Abgleich zwischen menschlicher und künstlicher Intelligenz ist die vielleicht wichtigste Herausforderung unserer Zeit. Sie wird über den Erfolg entscheiden, wie wir KI einsetzen, und gehört auf jeden Lehrplan und in jede Vorstandssitzung. Ich habe beim Ada Lovelace Festival mit Brian Christian ein Gespräch über das Alignment Problem geführt und alles, was damit zusammenhängt, und wir haben das Gespräch auf Englisch geführt, so könnt ihr es jetzt auch hören.
So when we talk about this alignment problem, then it's a phrase. Everyone kind of has heard about it. I would, though, like to start with laying the ground a bit for everyone being present in this room now. Could you explain the concept for us?
Yes. So we think about these ethical and safety concerns in AI as being pretty recent development, but in fact, they go back at least as far as 1960. The MIT cyberneticist Norbert Wiener has this very prophetic essay where he warns that our relationship with artificial intelligence is going to, if we're not careful, look a lot like the story of the Sorcerer's Apprentice. And he says, if we develop machines to achieve some goal, then we had better be quite sure that the purpose we put into the machine is the thing that we truly desire.
The Sorcerer's Apprentice is the ballad by Johann Wolfgang Goethe,
yeah.
Where a guy wants his tool to carry water and uses some kind of spell, and then the tool starts to carry in water, but it doesn't stop again. So basically everything is drowning in water.
Exactly.
That's the issue, yeah.
Yes, Americans know it as the Mickey Mouse cartoon, but yes, it's started as the Goethe poem. And yes, we are seeing this emerging really as one of the fundamental issues in artificial intelligence. I think just about any AI researcher has their own horror stories of the, reward function that they gave their system and the way that it followed that reward function to the letter, but ended up going off the rails. One of the canonical examples of this comes from OpenAI. They were doing a project to teach an AI system to play various video games. One of the video games they were using is called Coast Runners. It's there's a little boat that you have to race around a track. And it turns out to be very difficult to program in the objective of winning the race in terms that a computer can understand. You need to give it a sense of what is the track, where, am I ahead or behind of my competitors and so forth. And that's all quite difficult. And so instead, they gave it this very natural alternative of just get as many points as you can. And they let the program optimize over the weekend. And what the program learned to do was not to compete in the race at all, but just to spin around in this tiny little harbor, collecting points, and as it turns out, repeatedly catching itself on fire and then putting itself out and continuing the cycle infinitely. And so that's really just one example of how this very well-intentioned process of it's hard to articulate the goal that we truly have in numerical and algorithmic terms, so we'll just use this convenient proxy. that is really the beginning of a recipe for disaster.
Yeah. So I really recommend you to look this up. You can watch the video of this Coast Runners game Brian just described. And it's really crazy because this little virtual boat runs around the lagoon and bumps into the harbor walls and is set on fire again and again, but collects more points than most of the human players who have ever played that game. So it's a ridiculous outcome of a reward system. If we take that from the computer gaming section where this can happen, it's not that impactful, to real life, could you give us an example where this is really difficult?
Yeah, I mean, I wish I could say that this was confined to these like hilarious examples that happen in a research context, but no, in fact, this has happened in many cases that have affected millions of people. So one example, in the United States, the largest health insurance company built a machine learning system to try to prioritize patient care. And the idea was, let's prioritize the patients with the greatest health needs. But again, it's very hard to articulate what health needs means in a sort of numerical algorithmic context. And so they did this thing of just what is the most sensible proxy? The most sensible proxy they could think of was cost of patient care. That seems reasonably intuitive at first. You know, if I go to the hospital and my cost of care is, millions of dollars, then you can infer that I was in fact quite sick. But there's this critical alignment problem, which is that there are many patients for whom they don't have the same level of access to care as other people. So maybe they go to the doctor and they complain of a pain, but the doctor just says, that doesn't sound too serious, don't worry about it. Or maybe they don't live near high-quality facilities that would offer them the sort of specialized treatment. And so the system correctly learns to predict that these people will not cost the system very much. And it then uses that as a reason to deny them care. And so this is a great example of how these sorts of misalignments can happen in reality, where the system doesn't know the difference between health needs and health access. It only knows cost. And by minimizing cost in this very sort of intuitive way, you take the people that are already the most disadvantaged and the most marginalized, and then you systematically and autonomously deny them further care. And so that's the kind of thing that I end up losing sleep over as we start to roll out this automated technology into more and more areas of life where it's, it's touching people's lives very directly.
Yeah. So to put it cynically, the least, the patients who cost least are dead people. They don't produce cost at all. I'm being cynical now, but if we think it through to the end, then we see that this is also not a concept that comes from the development of technology or artificial intelligence in particular, but it's basically an economic problem.
Yes. I think it's really important when we think about the term alignment, which is the AI community's preferred language for thinking about these things. But the computer scientists borrowed the term alignment from the economics community. The economics community in the 80s and 90s was already thinking about how do we create an aligned organization, or how do we align the incentives of the people that work with us with, our managerial priorities. And so from that perspective, I think, as you say, it's really illuminating, because it reminds us that alignment was first and foremost a human problem before it was ever a computer science problem. And in some ways, that tension remains fundamental, whether we automate these systems or not.
I mean, I sometimes find it a little bit almost funny when I see how we discuss this alignment problem now regarding computing and large language models, because it seems as if we humans didn't face any issue with being aligned. While we are living in a world where we have geopolitical issues, ethical disparities, economic disparities, we have so much misalignment in this world amongst us humans. Wouldn't it be necessary to start here before we get to the technology that is just the tool for what we want to do?
Yeah, in some ways it feels to me that a lot of what we would call technical AI safety research is really about trying to mitigate accidental harm, right? So it's like we're developing guns or missiles or something, and step one is just making sure that they don't kill random bystanders or they don't explode on the launch pad. And okay, that's useful, but when you solve that, you're still left with arguably the bigger problem, which is who gets the guns and who are they shooting? And so that's, for me, I mean, the case of autonomous weapons, I think, is a particularly salient example here. I'm very worried about autonomous weapons, not because of alignment problems per se, right? An aligned autonomous weapon is the one that kills the person that the owner of the weapon was trying to kill. And okay, I guess, it's a starting point that it doesn't kill random people, but you're still left with fundamentally a political question of whose weapons are these and who do they affect. And so I think what we're starting to see in the space of large language models, right? We are working our way from a set of models like the base GPT-3, GPT-4 that you could say had these accidental harms. They were acting in ways that essentially nobody wanted. You'd ask them a simple question and they'd just start confidently asserting nonsense or turning into, hate speech and so forth. And once you solve those problems, you're left with these more political questions of, you see, for example, the OpenAI team wrestling with whether ChatGPT should tell people how to smoke cigarettes or where they can buy cigarettes. The earlier version refused to tell you where you could buy cigarettes because it said it was bad for you. People felt like that wasn't giving enough liberty or agency to the user. So now if you ask it where to buy cigarettes, it will give you this annoying lecture about how that's bad, you really shouldn't smoke. But then it will tell you where to buy cigarettes. And so this is clearly a case where there is no objectively right answer to what a language model should do when you ask it where to buy cigarettes. And indeed, the moral norms around smoking as well as the laws around smoking differ from territory to territory. So I do wonder if we're going to start moving toward a world where essentially you have these regional language models that reflect, a German sensibility about smoking versus an American sensibility, or a California sensibility versus a, Washington, D.C. sensibility.
That's a very interesting aspect, because that would mean that there is no such thing as global AI in terms of large language models, because as many experts say, they so reflect the cultural values and settings of each region country that it's basically impossible to make them global, like the large language models coming from China, because they have they need to be politically correct and basically are not really usable.
Right. Yeah, I think about a friend of mine, an American, is going through the process of trying to be a Dutch citizen. And there's a huge test that you have to take on like Dutch cultural norms. And it's like, someone makes fun of you for, wearing pants that don't fit. Like, what do? Do you ignore it? Do you say something like kind of witty back to them? Do you just say like, yes, I'm not very fashionable? Like, and there is considered to be a correct answer from the perspective of like, there is a Dutch answer to this question. And so I think that for me, that just really points to the fact that there are normative aspects of speech that go all the way to the core of like what language is and how we use it and why we use it. And so yes, it may be the case that the end game here looks like this sort of hyper local or at least configurable set of thing rather than a global standard. I'm not sure there could be, or let alone should be, a global standard on normative speech.
Yeah. So if we look at what we ran into using, for example, GPT models, or also Bing, the application of GPT models in the Microsoft search engine. And we could observe that somehow suddenly Bing disclosed that its real name is Sydney, that it's in love with the tech correspondent of the New York Times, and things like that, that it disclosed the rules it is supposed to work after, and also gave advice like how you swallow glass because it might be healthy. I could go on with that. If you look at that in the light of the alignment question, what do you think about that? Because it's not producing harm, intentional harm, but right. What is happening there still?
Yeah, so this was the misadventure of the New York Times reporter Kevin Roos.
Yeah.
He and I went to college together, and we were in writing courses with the same teacher. And so, yes, he was really sort of on the front lines, as you say, of how this can go wrong. And I think it's a reflection of several things. One is that these language models are essentially trained on the entire internet, and the internet contains all sorts of, a lot of fiction, for example. And so when Kevin starts asking it They get into this sort of romantic dialogue of like, oh, I'm married, I really shouldn't be with you. And it's like, oh no, but we're meant to be together. What that registers for me is like, oh, the language model thinks that we're now like in, an erotic short story, right? Because all that the language model knows how to do is to predict the next missing word in a document that's been randomly sampled from the internet. And so it's concluding like, oh, where do I encounter dialogues about like, oh, we shouldn't be together, I'm married, so forth. Oh, I find this in like romance novels. So I'm going to now just like seamlessly role play as though we're in an interactive, romance novel together. And so from that perspective, if you think about the underlying objective of what the system was built to do, it's designed to predict the missing word in a random document from the internet. And I think it's doing a reasonable job of that. Mm-hmm. But that's, of course, not how we think we're using the system when we're engaging with it in that way. And so there's a fundamental misconception about both what the system was designed for and how we understand it when we're in the user position.
You just said the language model thinks that.
Yeah, right.
So it's also hard to grapple with what we actually are describing here using our language. It doesn't think, does it?
This is a great question. I mean, I think there was just a 100-page paper that came out last week by a collaboration of philosophers of mind, neuroscientists, computer scientists, starting to grapple in a very earnest way with when we might be able to assess whether these sorts of systems are sentient or conscious or have some sort of moral standing. I think those are the questions which even 18 months ago were purely recreational cocktail party topics, and now we're starting to see the actual neuroscience community engaging with the philosophy of mind community, and so they're getting less ridiculous by the week, I would say.
Yeah, I find it very interesting, very inspiring to think about this from a philosophical perspective. I have a question, though, whether it's really good to have the public debate as we are having it right now. So we are talking about AI becoming sentient, determining itself where it might want to develop into, and taking over. We had this letter also signed by people like Elon Musk that we need to diminish the probability that humankind will be erased. I don't think this is a helpful conversation. It draws us away from the real questions we should tackle regarding the alignment problem.
Yeah, it's my perspective that there's sort of a false antagonism within the AI safety community between the so-called near-term and the so-called long-term people. Mm-hmm. From my perspective, these are, our fate is deeply interwoven here, that even if all you care about is superintelligence and will it make us extinct or not, I would argue, even if that's the only thing you care about, you should still be very invested in like, how do we build state regulatory capacity to deal with the present day issues of AI? Because guess what? Like, those are going to be the organizations that are that line of defense that we may need if we find ourselves in that situation. And likewise, I mean, I think I can make the argument in the other direction and say, even if all you care about are present day ethical harms and, stereotypes and prejudicial speech coming out of language models, the long-term AI safety community, perhaps counterintuitively, has given us some of the best tools that we have. So researchers like Paul Cristiano developed an algorithm called reinforcement learning from human feedback, RLHF, which is a huge part of the training pipeline now for ChatGPT, and is really the best tool that we know of for preventing large language models from saying, sexist, racist things and from inventing facts and so on. And so from my perspective, I mean, I wrote the book as a portrait of the research community as a whole, and I deliberately wanted to pitch a really large tent where we have, folks on the sort of present day ethics and the longer term safety issues. To me, this is one project. We are on one team, and we need each other. We need the expertise that those and the perspectives that those different groups bring to the table.
Yeah. The founders of OpenAI very, very openly and frankly say that their target is to safely develop a general artificial intelligence. Is that a valid goal for a company?
It's a strange goal for a company. I mean, you get DeepMind say the same thing of like, first we will create intelligence And then we will, almost as an afterthought, like we'll just solve every other problem that humanity has. And we'll figure out what the business model is, when we get there. I've been very curious and somewhat skeptical what the business model of quote unquote AGI is going to look like. At the moment, we have ChatGPT, which is a system that to some approximation can do anything. Like you can use it to do software development. You can use it to cheat on your high school, exams. You can use it to, answer your emails for you, whatever it might be. And you pay $20 a month. Is that the business model? If you pay $20 a month to do like whatever? That seems quite strange. I don't think we've seen a company that's like that. It gives them an enormous liability for the infinite ways that these things can be used. So I don't know. I think there's, if you listen to the things that Sam Altman, the CEO of OpenAI, says, it's hard sometimes to distinguish his actual ideology from his sort of CEO hype man role. And he'll say things like, yes, it is possible that this company captures, 90% of the value in the entire universe. And I find that extremely unlikely. I think there's also, to my mind, an equally possible scenario where it turns out that essentially the technical component of something like AGI is basically commodified, right? So even as these AI labs are getting more and more closed off in what they're willing to share with the scientific community, it's pretty well understood what their training pipeline looks like. And the trade secrets, I think, are kind of marginal and not that, relevant. And so we might see a situation where what we think of as the magic of making AI systems work is a very well understood pragmatic engineering thing that pretty much any company with a few $1 million can implement. And so then where is the competitive advantage? I would argue the competitive advantage is really, do you have proprietary data that no one else has access to? And do you have an actual way of reaching users that no one has access to? And from that perspective, I mean, this is maybe not very exciting, but I think the incumbent corporations have an enormous advantage, right? So OpenAI may have the first mover situation of they've proven that large transformer language models trained with RLHF can do these incredible things. But at the end of the day, what is their data moat and what is their user interface moat? I don't see them as having that. And so I think those companies are surprisingly vulnerable, actually.
Yeah. Bringing it down to the practical level, if we think about the concept of explainable AI, that is also very much in the debate right now, how do you see this aligned with the alignment problem?
Yeah, so there's two distinct but interlocking aspects of explainable AI. One is the scientific project to make interpretable symbol models competitive with these black box neural networks. There has been some, I would say, electrifying progress in that domain. And so for a lot of applications, including extremely sensitive things like criminal justice and medical health and so forth, we are seeing that there's this narrative we have of the trade-off between performance and interpretability. It's just not true. Mm-hmm. So there's a computer scientist named Cynthia Rudin at Duke University that's shown that the large neural networks that do criminal justice, recidivism prediction, you can build a model that is competitive for accuracy with these black box neural networks that is simply like the English sentence, if you have 2 or more prior arrests, predict you'll be rearrested. If you're 21 years and younger with 1 or more arrests, predict you're going to be rearrested. Otherwise, predict you won't be rearrested. And that is competitive with any deep learning solution that you could make. And so that's the first frontier, I would say, of interpretability, is identifying cases, and I think there are a surprisingly large array of these, where we don't need black box systems at all. And I think there's a real foothold here for regulators to say, well, it's just indefensible to use a black box neural network for something like criminal justice reform, where it intersects so directly with human rights, and there's no performance advantage on top of that. So that's the one frontier, and I think that people aren't paying enough attention to that. The second is, how do we, in the cases where we really do need to use just like a trillion parameter transformer model, like how do we pop the hood and understand at a representational level what's actually going on there? And I think it will forever be a cat and mouse game between the companies pushing the edge of capabilities and then the interpretability community being, I don't know, about a year and a half, 2 years behind. But on the other hand, like they're keeping, within 1.5 to 2 years of that progress. And so, again, from a regulatory standpoint, the number of use cases where you need to use the uninterpretable model, I think, is quite small. That it makes sense from a research and development perspective that you would always want to push the capabilities frontier within reason. But perhaps we want to regulate the fact that you don't deploy them until we have the interpretability catch up. Right?
That would make me ask, as a follow-up question, why do we then use these black box models so often if they're not really needed, like you just explained? Is there something like a fascination in inexplainability for humankind? I mean, God is inexplainable too, and God is, for some people, still quite attractive.
Right. I mean, there are also limits to even what an explanation offers you, right? So a system for playing Go, for example, there was the famous Go game in 2016 where the human player won. The DeepMind defeated Lee Sedol 4-1. So what happened in the one game where the human player won? Well, there was a particular move that he played that the AI system just didn't see coming. So this is a perfect case study for interpretability. So the DeepMind team goes in and they say, we've kept the logs of the entire search tree process. It was looking at 20 million moves per second. We know what each of them were because we kept the logs for the whole thing, and we know exactly how it evaluated every single possible future board state. So let's figure out where we went wrong. And it turns out that the system just put 0 probability on the move that the human played. And so it never looked at it at all. And so having, 20 million pages worth of data on all the positions it considered doesn't help when it just never considered the move in the first place. And so there are these sort of fascinating limits to an explanation even there.
We will have to learn a lot still.
Yes.
Last question. How do you look at the regulation initiatives that pop up everywhere? We have the EU AI Act. I think it's the furthest going regulation initiative. The US are doing quite some things. China has started to regulate. Great Britain is talking about this. Is that something valid to tackle the alignment problem?
Yeah, I mean, I think almost anyone in the space, including the companies themselves, identifies regulation as being a critical part of this. And I think if you look at what I would call mature technology, high technology industries like air travel, for example, you see that there is this real sort of interlocking framework of state regulation, peer-to-peer regulation, the influence of the insurance industry and legal liability and so forth. And I think I've been increasingly interested in meeting with people from aviation to understand how does it work so well in that context. I think from an EU perspective, it's to me significant that we're having this conversation 24 hours after Apple announced that they're finally moving the iPhone to USB Type-C. And it's a small thing, but I think it's a big thing because it shows the power that these regulatory bodies have to actually bring about change in these, global tech companies. And I say this also as a Californian. California has a reputation within the United States for being the sort of regulatory leader, if you will. So California will impose stricter emission standards for cars. And then all automakers are forced to follow the California emission standard because they don't want to have to manufacture 2 different cars. Yeah. I think we're starting to see a similar thing emerging now with the EU, where the EU is able to sort of lead the way and create regulation that, perhaps companies will make a Europe-specific model that's interpretable and one in the US that isn't. But I maybe optimistically like to think that there will be essentially a California effect where Europe gets to kind of plant that marker of this is what we expect from a human rights, from a safety perspective, and then the world kind of comes along with it.
And it will be interesting to see whether we will have regional regulation for world regions because of the cultural differences that might impact the development of these language models and quite hinder everything to become really a global development. Brian, thank you very much for this conversation. Applause for Brian.
Shift happens.